welcome to TokajTech Insider. Today, I would like to welcome Professor Yoav Yair to join us in a conversation about climate, technologies, and wine. Thank you for accepting our invitation. Professor Yoav Yair is planetary lightning enthusiast. His key research focuses on space weather, solar terrestrial interactions, and transient luminous occurrences. He managed the Israel astronaut mission in 2003 and carried out space-based experiments from a space shuttle and an international space station. In 2014, he was the head of Department of Life and Natural Sciences at the Open University, and since the same year, he's been a Dean Professor of School of Sustainability at the Rijksman University. Professor Yoav Yair, we're really welcome you here, and it's a pleasure that you accepted our invitation. My first question would be in this interview is, since terraforming, the Earth's climate has been through significant warming and then cooling. What is the difference between climate change and the changing climate?
Well, when we talk about climate change, we talk about man-made or anthropogenic climate change, which is induced by the fact that we, humanity, very industrialized society in the last century or so, well, I would say since the Industrial Revolution in the mid-19th century, have been emitting enormous amounts of greenhouse gases into the atmosphere. And by that, we are artificially modifying the temperature balance of the planet. So this is an unnatural climate change. There are, of course, natural cycles of the climate. We know long-term cycles such as the ice ages every 41,000 years or sometimes every 100,000 years, and there may be shorter time scales like 4 to 7 years of the El Nino, La Nina. Maybe some of our viewers know about this climate disturbance in the Pacific, but these are natural occurring changes and cycles which are not affected by humanity, or at least up until now have not been affected. Now humanity had changed the equation in the sense that we modified the atmospheric composition and enabled our atmosphere to actually absorb much more heat, which was supposed to be emitted into space. And the fact is that, and we see it by measurements from the ground, from satellites, from wherever we go, the temperature had risen significantly compared what it used to be before. So in climate studies, you always ask the question, okay, so we got warmer, but relative to what? So what we do is we take a 30-year average, let's say 1950 and 1980. Okay, so this period of 30 years, and we look at the global temperature, and then we compare the present day temperature to that average, and what we see is a clear increase, a global increase of more than 1.1 degrees centigrade everywhere, but in some places even hotter still, which is significantly affecting the way our climate is behaving now.
Wow, that's really exciting and frightening, I believe, at the same time, that it's man-made. I hope we can do something about it. But as we talk about climate, I think it's important we talk about weather, because that's what we're more kind of experiencing from the day to day. With technological advancements and new Earth observation systems, will we be able to forecast weather with 100% accuracy, maybe even control it? So well, let's say if I want rain, then will I be able to make it rain?
Well, these are two different questions. So let me first say that weather is what we experience on a daily basis. So if you go out today, Hungary, suddenly I see blue sky, where it was rainy and gray the days before, so which made me very happy, of course. But in Israel, on the other hand, you have 320 blue sky days every year. So different weather types manifested by the daily weather. So not only our daily weather is becoming more erratic, changes rapidly, and becomes hard to forecast, this is because climate patterns, which we used to be familiar with, are now disrupted. And so it's not easier. Even with our regular forecast methods to predict accurately the weather. And you asked about 100% accuracy. I think it's physically impossible to predict the weather everywhere with high accuracy and tell you, you should wear a coat if you go out to dinner tonight, and perhaps take an umbrella in Budapest because it's going to rain. We talk about probabilities, and we say, okay, it's a 60% probability, 75%, and you make the judgment. The user has to make the judgment. We probably will not be able to predict 100% because I'm sure you've heard, and maybe our viewers as well, of the butterfly effect. The butterfly effect means that small disturbances actually have a large effect downstream on the weather. So the famous sentence is, even a butterfly in the Himalaya can affect a tornado in Texas. So a slightly beautiful metaphor, but what it says is that even with our supercomputers, satellite, drones, all the high-tech technology, we will never be able to accurately portray the small-scale structure of the atmospheric flow and the meteorological parameters which are needed to make a forecast. Temperature, pressure, wind direction, radiation, humidity, all those need to put into equations, into a computer model, so that we can predict the weather. But we will never know very accurately. So there's always a hidden error within the equations and within what we call in physics the initial conditions of solving the weather problem. So in short answer, we will get better in forecasting the weather, really good for between 1 and 5 days, I would say above 95% accuracy, but you said 100 and I say probably not.
And we'll be able to control it. That's also.
Oh, okay. So that's the stuff of geoengineering bordering on science fiction. Let me explain why. Weather systems usually are very large and travel thousands of miles from one place to another. The atmospheric winds, the humidity fluxes, even pollution, emission, aerosol particles carried by the winds, all these are extremely hard to follow, even in real time. So if you want to affect, for example, the rain a certain cloud will produce, you have to be there at the right time, at the right altitude, when the cloud is ready to be influenced. And Israel, for that matter, was very famous in trying to increase rain yields from clouds, because we are a desert country. We are heavily reliant on winter precipitation, and climate change shows that we are going to get less rain. And so one of the things we tried to do from the early 1960s was to seed clouds with different chemicals like silver iodide, and try to impact the clouds such that it will rain more. But I should be honest that this was always controversial among the scientific community in Israel, and certainly in other countries as well. The experiments have not given, an undebatable result. Some say it enhanced rain, some say it did not affect the rain. But anyway, in Israel, the government decided 2.5 years ago to stop seeding clouds. So we're not doing that anymore. And I think other countries attempt to control the rain, or even maybe other weather phenomena, such as, for example, hail. And we will talk about hail in relation to wine, because even a short burst of hailstones coming during a severe thunderstorm can destroy a whole harvest of grapes, for example, or wheat, of vegetables and fruits. So some countries try to mitigate and fight hail production in clouds by shooting rockets with silver iodide into the cloud and try to diffuse the amount of hail or minimize it. This has been practiced in Georgia and other former Soviet Union republics, but to my best knowledge, not being done on a large scale anymore. China is investing a lot. The Gulf countries are trying to also look at weather modification. But the general view of this man-made interference with the weather is that it has very little chances of giving long-term successful results. Still, well, we pursue this. We are, humans have this feeling that they can control everything. And sometimes Mother Nature will show us that we can't.
Yeah, that for sure. But however, we do have many advancements in terms of technology, and space is almost unlimited. And we have so many technologies up in the clouds above us. Can we connect space and Earth? Can we use these technologies to benefit, for example, farming and agriculture, even wine culture? It's
definitely. So space assets, mostly space satellites. Let me differentiate between weather satellites, which give us early warning against incoming storms and thunderstorms and lightning, which I research. So this is particularly important to give head warning. So if you know there's a storm coming tomorrow, maybe you should make decisions about your plans, whatever they are, in order to use the forecast and almost real time. We are now able to give real time, well, I would say nowcasting, forecasting for now, which means in the next 6 hours, we can see if there is a gust front coming or a hail front or lightning. So we can say, okay, this airport, you should divert all the airplanes to another airport because it's soon going to be hail and snow or severe winds, so it's unsafe. So for example, this is a way we can harness real-time data from radars, from satellites, and from lightning detection systems to forecast nowcasting, which is real short-term, and protect ourselves and the safety of other people, but also economically, you need to take decisions in almost real time. Should I go out or not? Should I plant this harvest? Should we go and protect our vineyards? So many decisions are driven by real-time satellite data. So that's on the one hand. On the other hand, there's an array of satellites which look at the Earth at different wavelengths and try to sense, for example, the health of the plants. Do we see a disease spreading in some plants that we should pay attention to? Because you see, farmers have huge areas to cover. They cannot go everywhere, on a daily basis. So they need a bird's eye view, either from an airplane or from a satellite, to tell them, this plot needs water. Your irrigation system has not been working well. So please go there, hurry up and fix it. Because if you look at the territory of Hungary, huge areas, farming areas, and the farmers cannot be at the same place everywhere at the same time. So remote sensing, using drones, using airborne instruments, and certainly satellites can be immensely beneficial to modern day precision agriculture in terms of the product health, the soil health. Do we need to irrigate more or irrigate less? And of course, we are able to monitor dangers. For example, well, you don't have it in Hungary, but in the Middle East, it's a very known problem, and it's locust. Those swarms of plant-eating insects that can devour and destroy whole plots in a single day. They're coming from mostly sub-Saharan Africa, and they migrate in many directions, and they can eat in a single day huge amounts of plants. So you can monitor the progress of those insect swarms from a satellite or from an airplane and try to fight them by, I don't know, maybe using pesticides or other techniques to alleviate the problem. Otherwise, countries, and we know that, countries like Sudan and Ethiopia and Yemen have been affected strongly by recent outbreaks of those insect swarms, which are you would be surprised, are also driven by climate change because they get more rain in some parts, and which make them, able to spawn quickly, and then they become hungry and not enough food, so they have to move looking for food. Where's the next McDonald's? It's in Saudi Arabia. Let's fly there. Okay, so you get the point. Using space technologies is immensely valuable to monitor the planet health, but also to give real-time decisions that can help us tackle many, many problems that affect our food security, food production, and prosperity in general.
Yes, and maybe even water sustainability.
Yeah, absolutely, because we can sense the humidity of the air and of the ground by sensors that are in space, or we can look at clouds and we can calculate the amount of rain they're producing. Because you see, how do we know how much rain fell down in a certain place? We don't have a rain meter everywhere, right? And even weather radars, the radar that covers certain regions, is limited in range. So you don't see all the territory that you need to see. Only satellites do it better. They can fly above a certain country, look down and say, okay, this is the amount of rain that had been raining. And it also establishes a time series that allows us to monitor climatic trends. For example, are we going to have less rain in Central Europe, which is the current trend we are measuring? And satellite help us identify it and maybe prepare for it in the future.
So I think, as we established so far, climate change is real for everyone who's thinking that it's not. And we have to make preventive actions. But in the same note, I think we also have to adapt to a certain point, because change is not an immediate thing that we can do. And prevention and also kind of turning back time is also hard. So with climate change happening, and in here in Hungary, we definitely feel that it's getting warmer. The winter is getting a bit more, well, it's also warmer, and it's not snowing anymore. Will be a time in the future when we will be able to make wine, for example, in Poland or maybe even Norway, because of the climate change?
Well, you'd be surprised, but this is something that's already happening. And you probably would not believe that in the UK, in England, they're growing bubbly wine like champagne. Who would have thought that, champagne from out of France? Is it even possible? But climate change has opened new issues or new territories for growing wine. And there is a difference between the yield of vineyards that are exposed to warmer temperature, because wine has a very specific range that it can be good, between 12 and 22 degrees centigrade. So if it gets warmer, some northern countries will benefit from that because they will be able to grow wine, like the UK, even Belgium and Holland, Denmark. You know that even Sweden, started growing vineyards. I'm not sure about Norway, a little bit north, but Sweden does. And in England, they are growing champagne in Kent. So yeah, that's a trend. On the other hand, some places are getting too hot for good wine. So in Australia, which is a very known wine producer, the two problems occur. First of all, they have bushfires because of droughts and high temperature. And when you have a fire, the ash falls on the grapes and destroys the quality of the wine. So, and of course, wine ripens faster when the temperatures are warmer. So you need to be very well prepared to maybe change and adapt. So what the Australians are doing, they're moving some of their wineries to Tasmania, which is farther south and cooler. And I saw that in other countries, for example, in Argentina and in Spain, very famous wine producers, because climate change is already taking place, what they're doing is moving their vineyards up into a higher elevations in the mountains. So they need to cultivate new land. The terroir is good, but now you need to plant vineyards higher up than you used to do before, because as you go up, temperatures are cooler, especially at night, which is good for the vineyards. So we see rapid changes occurring. And even in France, you know, the famous appellation of the wine producing counties in France, like in Bordeaux, they are now trying to introduce new species of grapes into this very long traditional area of France. Also the same in Napa Valley in California, which has its own problems of drought and heat waves and temperature. So people are paying attention. I mean, this is a very active community. Also here in Hungary, where you have different geographical specializations, like in the Balaton region, you have these types of wine, in Pannonia, a different one, and then in the Danube, another kind of dominance of local species. And the slow changes will require readjustment of which grape you grow where and what wines you are able to produce. But in general, people think that we will have more sweet wines, which contains higher percentage of alcohol in some of the species. But for example, Chardonnay and Pinot Noir, which we all love, they need colder temperature. So we will have to see wine growers going to higher elevations in order to, you know, be ready for the climate that is coming.
Well, we talked about many types of wine, Chardonnay, Pinot Noir, and the sweet wine. I actually was at a winery a couple of weeks ago, and they told me that back in the day, they used to drink more sweet wine, and it's becoming a trend of the 20th century that we're drinking drier types of wine. It's more fancy. What's your favorite wine as a closing question, if you have any?
Yes, of course. Well, I have many, but one in particular. I love Merlot, which is produced in the Judean Hills in Israel. Israel is you know, we go back thousands of years in wine growing, all the way back, I think, 3,000 years old. We have our archaeological places that have been discovered that you have the wine infrastructure already in place 2,500 years ago. Certainly in the Roman period, and after that, Israel was very famous for growing all sorts of grapes. And it was a wine exporter to the Roman Empire, because we find, for example, offshore in the Mediterranean Sea, sunken ships with vases of wine, which was produced in Israel, in Judea. So now, in the last 25 years, Israel had become a sort of a wine empire, and we grow wines all across the country, from up north in the Golan Heights, in the Galilee, certainly in the Judean Hills near Jerusalem, south of Jerusalem, in the valleys, but also in the Negev desert. We use ancient techniques to grow wine in the desert, some excellent wines coming from the Negev highland desert, using irrigation methods from the Roman times and modern times. So yes, we are a very strong wine country, and I invite you to taste Israeli wines.
I would love to do that. Professor Yoav Yair, thank you so much for coming here to joining us in this conversation. It was very great having you.
Thank you very much. It was my pleasure.